So in this problem, we're told that the imaginary number I is defined as I squared equal to minus 1, and then we're asked to find the sum of this expression. So if you look at the answer choices, the sum is somewhat simple, which means that this term somehow simplifies, means there is some sort of a pattern. So the first approach will just simplify these terms using this definition and see where the sum goes. So we have I, so second term I squared is minus 1, but we have a minus of minus 1, so that's plus 1. I cube is I squared times I squared is minus 1, so this becomes minus I. So here we have minus I. Then I to the fourth would be square of I square, so minus 1 square, so that's 1. But we have a minus here, so this is minus 1. So if we just look at the first four terms, they add up to 0. Now if we were to look at the next four terms, which would be I5 minus I6 plus I7 minus I8. And in fact, if I were to factor I to the fourth here, this would be I minus I square plus I cube minus I fourth. And this is the sum I just did. That was 0. So this whole thing also would be 0. So we know that these blocks in 4 would all be 0. So now the question is, how far would that go? Of course, be careful about this trap here, because if we have 98 terms, 98 is not divisible by 4. So if we look at this, 4 times 4 is 16, so remainder 2. So in fact, we'll have these two extra terms. So up to I to the 96, that sum would be 0. And then we'll have I97 minus I98. So this sum is equal to this. And this is what I need to simplify. So here, again, I can write it as I times I to the 96, and then I to the 98. I know I squared is minus 1, so I can rewrite this as I squared to the half of that, 48. And then this would be I squared to the 49. So this is same as I times minus 1 to the 48, and then this is minus 1 to the 49. Now minus 1 raised to the power of an even, that would be plus 1. So that's just I. Now minus 1 to the 49 would be just minus 1. So I have I minus minus 1, so watch out for the minus. So it's I plus 1. So the answer is E. So this is one approach. The second approach sort of takes the inspiration from summing geometric series, and so I'll call this S, and we'll notice that the ratio here is I minus I, but I'm going to just multiply it by I, and we'll see what happens if we add these two terms, if things would drop out. So if I multiply by I, this becomes I square minus I cube plus I4 minus I5, and then here we have plus I98 minus I99. So if I add these two, we'll notice that these terms would drop out. All these terms, the only things left would be I minus I99. And so if I factor the S here, I have to just simplify this. I mean, this is another approach. You might find this to be more complicated, but I think this approach is also very useful to know for the exam. So I99, I'll start with that. That's I times I to the 98. As I did before, I squared to the 49. I squared is minus 1, and minus 1 to the 49 is just minus 1. So that's minus I. So this side becomes I minus minus I, so that's 2I. So my answer is 2I over 1 plus I. Now I need to rationalize this, so multiply and divide by the complex conjugate of the denominator. This product is the difference of squares, so that's 1 minus I squared. The top is 2I times 1 minus I. Now I squared is minus 1, so this is 1 minus minus 1, that is 2. So we have 2I times 1 minus I over 2. The 2 knocks out, then I multiply by I, that's I minus I squared. And again, I squared is minus 1, so this becomes I plus 1. So again, we get the answer E. So to recap, you can, of course, use either method depending on your preference, but the answer is E.